Good morning, year 10. Good morning. Good morning. Good morning. Nah, I need to turn that off. How's it going, guys? You guys were here awfully early. How come you guys were here so early? I was like, there's like 7 people already waiting, and I was like, what's going on here? Nick's in. Nick's in the house. Got Con, got Ben, smashing it already. Yeah. Doing well. So yeah, why were you guys here so early? You're our last lesson. Ah, I see. Okay, that makes sense. How are all you guys getting on with calculations? How are you finding it? I know I've been setting you guys a lot of homework with very little time to do it, but I promise you it's worthwhile doing it. We got sent out early. Fair enough from the last lesson. That's fair enough. Fair enough. Yeah. Morning, Wen. Mr. Duncan, you're always here. Tong, thank you for letting me know. You're just a star. You're always here. Winner. Ruby's here. Sup, Ruby. Do you know what? In 2 weeks' time, if we're not back in school, I reckon I might just snap and just go full on crazy. I'm here, but my other class is still going on. Oh no, your other class is still going on. What other class is that? Who's overrun on a lesson? Sheesh. Hola, Victoria. Hola. Victoria's in. Maison. Missing. Is Rue here? Drama. Oh, right. Wow. You're having a drama. Oh, cool. Drama lesson over the internet. How does that work? How does that work? I don't know. I'm here. Hey, Rue. Rue, is Kieran here also? Is Kieran here? Good morning. Good morning. Guys, last lesson before Easter. 2 weeks without chemistry. So sad. I was going to ask then if anybody was going anywhere exciting for the Easter holiday, but yeah, no one is. It's funny. It's funny. I'm just full of all kinds of all the good jokes. I'm missing Ashley. I'm missing Shan, Anna, Kieran, Toby. They're all in drama, aren't they? Ashley's here. Yay! Ashley, I definitely didn't think that you were going to miss our lesson. Toby's coming. He's here. So Kieran's here, is he? All right. Tell Kieran to sort out his YouTube channel so that he can at least come and watch. Can you tell him to sort that out? Anna, hi. Whoop, whoop. Just Shanley and Toby to go. It's really weird every time I say Toby's name because it's my name. It's weird. Okay, so Shanley. Yo, Shan. And just Toby to go now. Look at that. I have arisen. Now, Toby, that there is good learning. Well done. I'm here, Mr. Durr. What did you just call Mr. Durr? Mr. Anyway, I'll just move on. Amazing. I've got a full house, as always. Look at that. You guys are all here. Thanks, guys. Bye. Let's crack on. Whoop, whoop. Okay. So today's lesson, folks, is on empirical formulae. But the first thing I'm going to do is I'm going to go through the homework. How many people handed in their homework? Let's just do a quick check on the classroom. I will share my screen. Share. There you go. Hide. Let's see how many of you guys handed in your homework. There we go. Moles in solution. 10 handed in, 10 didn't. Oh, come on. Anna hasn't turned it in. Ben hasn't done it. Harrison needs to be deleted. He shouldn't even be there. Isabel, Victoria, Kieran, Minso needs to be deleted as well. Oh, man. Got people on here that shouldn't be here. Perfectly balanced. So true. Right. Okay, so let's go through it, folks. You can mark it as we're going through. Okay, so this was exactly the same process, but in a solution setting. I think everyone kind of starting to figure this out now. So we have been given 25 centimeters cubed of 0.2 barium hydroxide. Let's write, so I go, so step 1, get to moles, find moles. Barium hydroxide, number of moles is C times by V over 1,000. Concentration is 0.2, which is that guy, times by a volume of 25 all over 1,000 because I'm in centimeters cubed. And I'm going to spit out 0.2 times 25 all over 1,000. And I get 5 times 10 to the minus 3 moles. Step 2, use the ratio. Yeah, we're kind of getting used to this. My Wi-Fi wasn't working, but I did it. Oh, okay. Thanks for Joy. Thanks for letting me know. Ratio is a 1 to 2. Yeah, because we're trying to find calculate the concentration of the hydrochloric acid. Yeah, so the ratio is 1 to 2. There's your mark at GCSE. And we're going in that direction. So it's a times by 2. So I'm going to do 5 times 10 to the minus 3 times by 2 times by 2, already on my calculator, gives me 0.01 moles of hydrochloric acid. Step 3, get out of moles. What am I looking for? I am after the concentration of the hydrochloric acid. Number of moles equals C times V over 1,000. I'm in centimeters cubed. Reorganize. Bring the 1,000 up, times it by 1,000. Yeah. And then bring the V down. Yeah. Over V gives me C. Right. So moles is 0.01 times by 1,000 all over a volume of the hydrochloric acid of 22.8. So multiply that by 1,000. Divide it by 22.8, and I get an answer of 0.43, can make that point bigger, 9 moles per Diem cubed. Tick it if you got it right, folks. Whoop, whoop. Next. Right. 25 centimeters cubed of sodium hydroxide, yet reacts with 25 0.0 hydrochloric acid. Right. Question, calculate the concentration of the sodium hydroxide. Right, perfect. Get to moles. Step 1, get to moles. Number of moles equals C times V over 1,000. Gives me concentration, there's C, 0.1 multiplied by 25 all over 1,000 gives me 0.1 times by 25 all over 1,000 gives me 2.5 times 10 to the minus 3 moles of hydrochloric acid. Amazing. Now, ratio, step 2, ratio is 1 to 1. There's an invisible 1 and 1 there. That's great. So the moles is the same. So NaOH equals 2.5 times 10 to the minus 3. Don't even need to do anything with it. How nice is that? Step 3, get out of moles after concentration. Number of moles is C times by V over 1,000. Bring the 1,000 over, yeah, equals C times V. Bring the V down. N times 1,000 over V gives me C. Right, so times that number by 1,000. So that becomes 2.5 times 10 to the minus 3 times 1,000 divided by 22.5. 22.5. And I get an answer of, this is where I really wish I'd just left myself a bit more space. Nah, lol. Which gives me 0.111. moles per Diem cubed. Yeah, winner. Next. Calculate the concentration in grams per Diem cubed. Oh, that's a clever trick, isn't it? We've done this, though, on the previous homework. To go from moles per Diem cubed down to grams per Diem cubed, yeah, the Diem cubed hasn't changed. So, in fact, all we're doing is going from moles to grams. So, number of moles is grams over rams, but I'm after grams. So, bring the rams over, times it by rams, yeah, gives me grams. Right, so I just need to multiply this by sodium hydroxide's MR, 23 plus 16 plus 1, 40, I believe. So I'm going to take 0.111 times by 40, multiply that number by 40, and I get 4.44 grams per Diem cubed. Does that all make sense? 3 sig fig. Oh no, it's 3 sig fig. Oh, that is 3 sig fig. Should you put the reoccurring sign? No, yeah, 3 sig fig. There you go, 3 significant figures. So you can just do 4.44. That works. Next, what volume? Oh, they've done a little switcheroo. What volume of rubidium hydroxide reacts with 25 nitric acid? Right. Step 1, get to moles. I've got everything I need for nitric acid. Yeah, so the nitric acid, the HNO3 moles, number of moles, is C times V over 1,000 because I'm in centimeters cubed. Switcherooming. That's really funny. I shouldn't find that funny. Do we lose a mark for forgetting 3 sig fig? No, I don't mind, Ruby. I don't know, because I am testing your chemistry calculation skills, not your 3 significant figure skills. So no, absolutely not. Next, concentration 0.24 multiplied by a volume of 25 all over 1,000. 0.24 multiplied by 25 all over 1,000. 6, sorry, my calculator went mad. 6 times 10 to the minus 3 moles. Moles of 9. Step 2, the ratio. The ratio, which is awesome, it's a 1-to-1. Love it. I love a good 1-to-1 ratio. Makes me happy. 1-to-1. That means the moles are the same. That's awesome. So, therefore, moles of RBOH is 6 times 10 to the minus 3. How awesome is that? Same number. Step 3, get out of moles. What am I after? Volume. Number of moles is C times. Never, ever learn a rearrangement. Just learn to reorganize it. But would you lose the mark in an exam? You would lose one of them, yes. And in Victoria, these questions are actually 3 marks in an exam. Yeah, so you'd probably lose the final mark for the answer. But good question. Thanks for asking. I need to reorganize this for volume. First of all, bring the 1,000 up. Remember, bid mass. Yeah. Brackets, indices, divide. You've got to do the divide first. So bring the 1,000 up. Yeah. Equals C times V. But this time I'm after volume. Bring C down. Yeah. Number of moles times 1,000 over C gives me V. Right. Let's input my data. I've got 6.6 times 10 to the minus 3 multiplied by 1,000 all over of a concentration of 0.150 times 1,000, just gets rid of the 10 to the minus 3, by the way, divided by 0.150. And I get 40.0 centimeters cubed. Sorry, that's the centimeters cubed song. Big hit in the 80s. Sorry, you might not have heard of it though. Next, suddenly realizing that people are listening to this. So I've got 25 sodium hydroxide. Yeah, reacts with 18 sulfuric acid. Calculate the concentration of the sulfuric acid. Step number 1, get to moles. I've got everything I need for sodium hydroxide. Yeah, so NaOH, number of moles is C times by V over 1,000. Yeah, concentration is Him, 0.2 times by a volume of 25 all over 1,000 because my volume was in centimeters cubed. 0.2 times by 25 divided by 1,000. Boom. 5 times 10 to the minus 3 moles. Next, step 2. What is the ratio? Yeah, the ratio is a 2 to 1. And I am going in that direction. That's a divide by 2. So I'm going to take 5 times 10 to the minus 3, divide it by 2 to give me 2.5 times 10 to the minus 3. Just going to do my calculator. Yeah, there you go. Yep. Moles of sulfuric acid. It's nice to be really clear in our working out. Step 3, get out of moles. Yeah, so let's get out of moles. So we now need number of moles equals C times by V over 1,000. What am I after? Calculate the concentration. Number of moles times 1,000 equals C times V. And then I'm looking for concentration, bring the vol down. Number of moles times 1,000 all over V gives me C. So I've got 2.5 times 10 to the minus 3 times 1,000. The 10 to the minus 3 just disappears. And the volume of sulfuric acid was 28.7. So times that by 1,000 makes the 10 to the minus 3 disappear, divided by 28.7. And I get an answer of 0.0871 moles per dm cubed. Winner. Good job. Last question. Look at this. Smash through this. This has been nice and easy, hasn't it? Cruising. Calculate the concentration of the ethanoic. Okay, so sodium hydroxide. Got it all. Yeah, and then I've got a volume of ethanoic, and I'm calculate the concentration. Okay, so step 1, get to moles. I've got C, I've got V. Number of moles equals C times by V over 1,000. Put in my numbers. Concentration is 0.15 times by a volume of 25 all over 1,000 gives me 0.15 times by 25 over 1,000 gives me 3.75 times 10 to the minus 3 moles. Christmas moles. Step number 2, ratio. The ratio is a 1-to-1, I guess. Yep, amazing. How awesome is that? Yeah, it's a 1-to-1. So ratio is 1-to-1. Therefore, 3.75 times 10 to the minus 3 moles of ethanoic acid of CH3COOH. It's a cool. That there is a structural formula from organic. Right, step number 3, get out of moles. What am I looking for? Looking for concentration. Number of moles times 1,000 over volume gives me C. Right, 3.75 times 10 to the minus 3 times 1,000, because I was in centimeters cubed, over the volume. What was the volume? The volume of the ethanoic acid was 30.3 centimeters cubed times 1,000 divided by 30.3. And I get an answer of 0.124 moles per dm cubed. Yeah, there we go. Last question of the worksheet. Calculate the concentration in grams per dm cubed. Right, okay. So, done this again. So, we're going from moles per dm cubed to grams per dm cubed. The dm cubed isn't changing, so I ignore it. I just need to do that to that then. So I'm using number of moles equals grams over rams, but I want grams reorganized. Moles times rams gives me grams. Right, so how much does ethanoic acid weigh? Yeah, there's ethanoic acid. Carbon is 12, and there's 2 of them. Yeah, so that's 12 times 2. Going to add that to hydrogen, which is, of course, which is 1. And there is 4 of them, so times that by 4. And then I'm going to add that to oxygen, which is 16. And how many of those do I have? I've got 2 of those as well. Yeah, I'm going to say 63. I think I don't know, 12 plus 12 plus 4 plus 16 plus 16. 60. Oh, so close. There we go. So all I need to do is multiply that by the moles per dm cubed, times that by 0.124. So multiply that by 0.124, and I get an answer of 7.44 grams per dm cubed. Tick it if you've got it, folks. Winner! And there's the end of the worksheet. Smashed it. You realize, guys, you just run the process, run the steps, you're golden. This is easy. Yeah? I love it. It's great. Whoa, Mr. Duncan hasn't said moles yet, and he's only said moles. Mole. Okay, guys, you can mark your sheet. It is out of 1, 2, 3, 4, 5. Oh, hang on, 6, 7. It was at a 7. So you can give yourself a mark out of 7, folks, and then just post on the classroom so that I know. Who are you and what have you done with Mr. D? Oh, you guys are funny. Right, title of today's lesson. Empirical formulae. Empirical formulae. Amazing. Okay. I'm going to give it that little tip there. Right. So, empirical formulae, learning objectives. Yeah, know what it is. I actually put them onto the, so define, know, knowledge, define emp form. Number 2, use steps. Yeah, its use. Oh, no, yeah. Understand its use. Yeah, hang on. And then the third one, understand its use, be able to calculate. Yeah, Mr. D, you spelt it wrong. What? Empirical. My bad. I had experiment in my head. That's what it was. It's definitely what it was. Lol. So be able to calculate it. Able to calculate. Calculate. Molecular and empirical. Emp and mol. Right. Okay. So first thing we need to do is we need to have that conversation about what the words empirical means. We need to define it. So I'm just suddenly realizing I want to get rid of all of this junk here. Just going to erase all of this. Give me a bit more space. There we go. Can just run down the side of it then. There we go. Okay. So you guys have been doing chemistry for a while now. Kieran says he got 7.43 for the last question. He said that he left an exact. I did too. Yeah, that's fine. He says you rounded prematurely. Yeah, I did. All right, Kieran. All right. Right, empirical formulae. So you guys have been, example, empirical form. So, ... Definition. The simplest whole number, I shouldn't do that. The simplest whole number whole number ratio of the simplest whole number ratio of atoms of each element in a compound. Now, I know that that doesn't each element in a compound. I know that this doesn't really mean an awful lot. So what I need to do is I need to show you an example of this. So there's the empirical formulae. Yeah. I actually quite like the word form. Hi, Sian. Nice to see you. Oh, you just tacking on to one of my year 10 lessons. Oh, it's nice to see you. Hi, Sian. Oh. Right. So just to quickly backtrack on this. So you guys have been doing chemistry now long enough. I'm really struggling to zoom. It wants me to go down. I'm just going to underline that for a minute. By the way, that there, super important. Yeah. But there's also a molecular formulae. Now, this is what you guys have been using since you started with me in year 9. Yeah. And the definition of the molecular is the actual number of atoms of each element in a compound. It's the actual number. Yeah. The whole other class did it last lesson. I don't know what you guys are talking about now. Don't you have a bio lesson? Yeah. Anyway, so what does this actually mean? What this means, that there, molecular form, is that this is what you've been given all the time. So when you get given sucrose, actually it's glucose, isn't it? Got to be careful there. Yeah, glucose is C6H12O6. And all of you here, every one of you, understands that this is a molecular formula, molecular form, yeah? And there are actually 6 atoms of carbon. Yeah, you know this. There are 12 atoms of hydrogen, and there are 6 atoms of oxygen. Every single person in this room understands what that formula is trying to tell you. You recognize that it's telling you the actual number of atoms of each element in the compound. Yeah? So what's the simplest whole number ratio? Well, we can take that formula of glucose and we can change this from a molecular to an empirical. There we go. So that there is the simplest whole number ratio. Yeah, I'm underlining whole number. Is everyone okay with this concept so far? Yeah? This is not overly difficult. It really isn't. It's just this idea of we can simplify it, yeah, into its simplest version. Right, I'm going to give you some questions now, just for you to apply this, yeah? So, question number 1. I have got I want me to make my pen a bit thicker. Oh, wowza. It means that I'm zoomed right out, I think. Yeah, I'm zoomed nearly... Oh, no, hang on. I am zoomed much further out than I usually am. So, I'm going to actually zoom in even further than that, I think. So, question number 1. I'm still going to make my pen thicker. H2O2. This here, this compound is called hydrogen peroxide. You guys have to know this guy. Hydrogen peroxide. It's not water. It's a type of bleaching agent. It's an oxidizing agent as well. Hydrogen peroxide. This is the actual number. This is the molecular form. Yeah. What is the empirical, please? What is the emp form? What is the emp form of that? Not complicated. Pause the video. Yeah, have a go at it. You probably should already have finished by now. Yeah, this is the molecular form. The actual number of atoms. Well done, Ben. Spot on. Good man. Thank you. It's just ho. Oh, ho, ho. Look at that. I've got ho, ho, ho on the chat. It's like full morels. Oh, no. Okay, so I think everyone kind of goes, I get it. Yeah. Let's go for something a little bit more tricky. Let's go for question number 2. I'll leave that one there for a minute. Q2. What about this one? Sodium chloride. Yeah. This is a molecular. It's not actually molecular, by the way. It's actually a formula unit, technically, but that's the same thing. Yeah, this is a formula unit, but it's the same thing as molecular form. Same thing. Mole form. Yeah. What's its empirical? Emp form? You guys are so funny. M form? Everyone's going, what? Well done, Shan. It's exactly the same. Boom. Yeah. That is the empirical and the molecular in this case are the same. Yeah. And they're going, so they love to ask this trickery. I know, Toby, but they actually love to do this in GCSE exams. They'll ask you to explain why you can't give its empirical. And you say, because it's already in its simplest whole number ratio. Yeah. Already simplest whole number ratio. I shouldn't do that. It's really bad to do that. Whole number ratio. Yeah. Already there. Let's go for another one. Let's go for question number 3. Let's go for something a bit more complicated. Let's go C4H10. Try that one. This is, does anyone want to tell me the name of that, folks? Year 9 chemistry right here. Year 9 chemistry. Yeah. What's this called? Let's see who can name that first. Everyone's like, oh no, I did this in year 9. I can't remember any of it. Well done, Rue. Well done, Shan. Well done, Ben. Good. Well done, guys. It's a beaut. Oh, me and you, Shan. We're like on the same wavelength, me and you. This is butane. Yeah. What? So this is its molecular form. This is mole form. Yeah. What's its emp form? Emp form, please. Oh, Harris, think again. Check. Look what you've written, and you'll see why you're wrong. There we go. Thanks, Harris. C2H5. Yeah, well done. Good job. No, what? Ruby, don't forget, you've got to do both. Yeah, what you're doing is you're dividing the whole thing by 2. Yeah? Yeah, that's okay. I totally understood that you got that. It was a mistype rather than anything else. Yeah. Okay, cool. Let's go again. One more, and then I'm then going to tell you why we care. So, one more. I need to make this really hard. Really, really, really hard. ethanol. Displayed molecular mole form, displayed form. Yeah, what's the EMP form? EMP form? So see who gets it first. The same. Well done, Shan. Yeah, it's the same. Now, they do this again. They will say, explain which element stops you from simplifying it. And that is? Question, what stops simplification? And the answer is oxygen. Well done. Good job. Yeah, spot on. Absolutely right. No, not O2, Shan. O was correct. Oxygen, the oxygen atom. Yeah, you would have said that guy. Yeah, the O is what stops it. Because the O is already at number 1. You can't get that down into a lower number. Okay, so the big thing now is, why do I care? Yeah? Why do I care? Yeah, why do I care about this? And why do we even need this? Because would everyone agree an empirical formula is a bit rubbish? So why do I care? Well, statement, bullet point, empirical formulae tells us very little. It tells us almost nothing. Yeah? Tells us very little. It just tells us the simplest whole number ratios of atoms, isn't it? Well, would everyone agree that if I give you this, if I said, let's go one more question. Yeah? C4H10. So these are mole form. You can then put the empirical underneath it. EMP form. C8H, double it and add 2 to make octane, petrol, 18. Yeah. Then let's go C30H, double it and add 2, 62. That's, I've no idea what that's called, but it's long. Let's go for C50H, double it and at 102. I don't even know what that's called either. No idea. So what's the empirical form for these guys? It's a really good question, isn't it? I think I might have made a mistake here, folks. I might have literally just made a mistake. I think I made a mistake. Drat. Oh, no. Do you know what? Hang on. Ignore me for a sec. I've made a mistake. There was a game I was trying to play here, folks. I'm really sorry. I'm going to make them all alkenes. Let's make them all alkenes. I'm sorry. You guys are going to be spitting feathers over your notes being a mess. There we go. I wanted to make them all alkenes or cyclos. Let's not talk about that one. Alkenes. Made them all alkenes. I know, I'm sorry, Shan. I'm sorry. Why? You're going to see why. Look, what's the empirical formula? Exactly. So everyone realize how useless empirical is. Because in reality, the empirical formula for an alkene is just CH2. If someone gave me an empirical, it could be any alkene. any. That's completely and utterly useless. So why do we care? The reason is, folks, machines. So, chemical analysis. Chemical analysis. Obviously, this is sometimes referred to, and I'm actually going I shouldn't do this. Chemical analysis comes under two branches, chemical and, I should have just done analysis. Yeah, but I want to talk about machine analysis in this case. Machine analysis. So if you get given, so by the way, this comes from crime scenes, just so you know. Chemical analysis has been driven forward by the desire for people to catch criminals. Yeah, we have to be able to find tiny things at a crime scene, and we've got to be able to figure out what they are. So chemical analysis has evolved through that medium. We've constantly wanted it to get better. So let's say you find something at a scene of a crime. Yeah, you find some kind of substance, a white powder perhaps. Yeah, you find a white powder at the scene of a crime. Now, you could do all kinds of cool chemical tests to it. You could do a flame test. You could add some sodium hydroxide. You know, you could do all these cool, you could add some silver, you could have nitric acid followed by silver nitrate. You know, you could do all of these chemical tests. But in reality, the first thing they're going to do is put it through a machine. Yeah? And that machine is called, we're going to put through machine, yeah, unknown white powder, put through machine, and that machine is called a mass spectrometer. A mass spectrometer. Yeah. Now this machine is really cool. It literally does exactly what it says on the tin. Or you could eat it. Toby! Yeah, if it was cyanide, yeah, you could eat that all you like if you like, Toby. So a mass spectrometer literally says what it does on the tin. It is a mass spectrometer. It measures mass. So what it does, that white powder is going to spit out data. Yeah, it's going to spit out, number one, it's going to spit out mass numbers. So it's going to spit out carbon 12. It's going to spit out hydrogen 1. And it's going to spit out, oxygen 16. What it's going to do is the mass spectrometer smashes everything up and then tells you what the pieces are that it was made from. So it tells you their masses. So it literally tells you the elements by looking at their mass. Yeah? Just to tell you, it comes out on a graph. And on the graph, there'll be a peak at 12. There'll be a peak at 1. There'll be a peak at 16. Yeah? And you go, oh, wait, so that's oxygen. That one's carbon. And that one's hydrogen. It's spitting out data. Agreed? The next thing is the horizontal axis. It is also going to spit out the percentage. Yeah? It's also going to spit out that this contains... Now, I've got to be careful here, folks. Sorry, I need to run a bit of maths really quick. So it's going to spit out a percentage for each one. Carbon was 40%. Hydrogen was 6.6%. And oxygen was the rest. Yeah. So the first thing you're going to do is you're going to calculate what the rest is. Well, you put in an unknown substance. We now know what it's made from. Yeah. And we can now say, right, well, this is a percentage. It's got to add up to 100. So I can work out what the oxygen was. 100 minus 40 minus 6.66. Okay, Yeah, 6.6. I'll just do 40, hang on, 100 minus 40 minus 6.6, because that's what I've given you. So the first thing I'm going to get is I'm going to now realize that the oxygen is now 1 mark in the exam, 53.4. It's not complicated. 53.4% makes total sense. Yeah, right. Okay, so now what you can do, by the way, it's going to also give me one other mass. And you're going to love this, guys. It gives us one other. Now, I just want to circle this data. Yeah, there's my percentage mass data. Yeah, well, it's also going to give me one other bit of information, the total mass. And they're going to give you the total mass, otherwise known as the MR. It's going to give you the relative molecular mass, the RMM or the MR. These are the same thing, remember? Yeah. And it's going to tell you that it's 180. Right. Now what they're going to do is they're going to ask you to calculate the empirical formula from this data. That data there is going to give me the EMP form. And then I can use the EMP form and this data to get to the molecular form. Yeah, we can just use the data to spit it out. This is done by machines in reality, but I have to teach you how to calculate it yourself. Yeah, okay, so guys, here are your steps. Can you put steps in empirical formula. Yeah, here's the steps. That doesn't look like an M, does it? Empirical formulae. I've ruined that. Right, step number 1. I should do it. Step 1. Gonna make my pen thicker. I think I'm getting, yeah, I've got proper. Step number 1, swap the percent sign, change percent sign to grams. Percent sign to the gram sign. This is what I like to also say, percent to mass. Percent to mass. Step 2, now change mass to moles. Percent to mass, mass to moles. Last step. 3, divide by the smallest. Divide by the smallest. Percent to mass, mass to moles, divide by the smallest to find the ratio. Right, let's run the question, shall we? So, I have got, so here's my question. I have got X, compound X, compound X, and it contains 40% carbon, 6.6% hydrogen, and 53.4% oxygen. Calculate empirical. Yeah, calculate EMP form. Okay, step 1, list down my elements. Makes it easier. Swap the sign, percent to mass. Yeah, percent to mass. Next one. Now I've done the percent sign to grams, done it. Step number 2, grams mass to moles. Mass to moles divided by, how do I, number of moles is grams over rams. How much does carbon weigh? I'm just now counting particles, remember, folks. Empirical formula is we're counting particles. Yeah? So I'm just going to count them. So grams over rams. Hydrogen over 1, oxygen over 16. Now, you're not doing them in their pairs because we're trying to count atoms here rather than molecules. Empirical formula is the actual number of atoms. Sorry. Yeah, that's molecular. Empirical, the simplest whole number ratio of atoms of each element in a compound. So we're counting atoms, not molecules. Yeah, so that's the only difference here. So 40 divided by 12 gives me 3.33. Hydrogen, well, that's easy. It's 6.6. And then oxygen, 53.4 divided by 16, and I get 3.33. Right. Now what do? Divide them all, divide all by the smallest. Right, well, the smallest. The reason why we're doing this, of course, you guys probably got this from the water crystallization question. I'm trying to get it to the simplest whole number. Yeah. All right, Roo. All right. 6.6 divided by 3.33 gives me 1.98, aka 2. And this one is 3.34 divided by 3.33 gives me 1.00. Look at that. Right. So guys, the simplest whole number ratio is carbon 1, hydrogen 2, oxygen 1. But I don't need the ones. There we go. This is the EMP form. It's the simplest whole number ratio. Right. So now that we've worked out the empirical, percent to mass, mass to moles, divide all by the smallest to find the ratio. Divide by smallest to find ratio. Yeah? Okay. Now that we've got the empirical formula, what did they tell us in the question? They told us that the MR was 180. Oh, well, hang on a sec. If this is the simplest whole number ratio, when we were doing our questions before, what we were doing is just dividing them. Yeah? We were dividing them by the biggest number possible in order to find out their simplest bit. Well, what we need to do is we need to multiply it back up. So how much does the empirical weigh? Carbon is 12, hydrogen is 1 times by 2, and oxygen is 16. Total there, 12 plus 2 plus 16. The empirical has a mass of 30. Well, what have they divided it by? 180 divided by 30 gives me 6. The actual formula times everybody by 6. So that times by 6 is C6H12O6. It was glucose. No, yeah, glucose. Woo! Boom! All from a machine. Just because it spits out me data. That's it, folks. Our lesson is done. I will post on the classroom the empirical questions. I'm going to give you, we've got 3 minutes. Toby was right. Yum. Roo. Now that's funny. That's great chemistry. Well done. Are we ready for one more question? I think we should do one more. One more question. Let's do, trying to think of something that might be entertaining. Let's do compound Y contains ... I want to I'm just quickly trying to find something. Blimey. Oh, I can't. That doesn't work, does it? Devastated. Okay, I'll just oh, just do something, you know. Yeah. Hang on. Oh no, I'm really stuffing this up. I'm sorry, folks. Mood. I'm so very confused, but I somehow get it. I just realized something. The murder weapon was sugar. The murder weapon was sugar. Yes. Well, yeah, kind of. But yeah, pretty much. So contains carbon 86%, hydrogen the rest, MR, gonna zoom out, MR114, I think. Yeah, there we go. Guys, give me the empirical and then give me the actual. Pause the video, have a go, and now I'm going to walk through it. So first thing is list my elements. It makes it easier. Put my percentage underneath. Calculate hydrogens. 100 minus that, I think, is 14%. Right. Change the percent sign to a gram sign. Now change that into moles. The devil. Change that into moles. 86 divided by 12 gives me 7.17 moles. This is moles. And that, of course, is 14. Oh, that's awkward. Divide them all. Have I made a mistake there? Eek. About to find out. Divide them all by the smallest. Yeah, divide by smallest. Just run your steps. 7.17. That's going to give me 1. 14 divided by 7.17. Oh, there you go. 14 divided by 7.17. Have I made a mistake here? I think I've made a mistake, folks. Yeah. I've made a mistake. I know I have. It should have been 84%. Sorry. I made a mistake. I'm sorry. Made a mistake. This is the problem when you try and make up questions. That now becomes 16, you see. And that makes a big difference. Yeah. Sorry. You guys are going to hate me. 84 divided by 12 gives me 7. Dead on 7. Right. Then 16 divided everybody by 7. That gives me 1. 16 divided by 7 gives me 2.28. Right. Now that's a problem, guys. Yeah. I get 2.28. technically. Now, Vic. Oh, I think I've overshot my lesson, haven't I? Right, guys, there's a problem. That should have been a whole number, but it's not a whole number. Yeah? The problem is that's a third. Is it a third? No, it's not. It's actually it's more like that's an yeah. How do I get that to a whole number? Yeah. How do I get that to be a whole number? Times by 4? Times that by 4. No. Times by 3? No. Guys, I'm so sorry. I've stuffed this up. I've given you a really bad question. I'm so sorry. This is an absolute nightmare. I've made a mess of this. It's really, I shouldn't make up questions. Scratch it. Scratch it. I shouldn't make up questions because the problem is I'm using data which I'm trying to calculate in my head without writing anything down, and I'm stuffing it up. Yeah. Ignore that. Ugh. Do you know what? I don't care. I'm going to leave it at that, folks. That's really funny. I'm going to abandon it. Only partly because we've run out of time. But guys, I will post on your look. Oh, do you know what? I'm such a look. Share screen. Darn it. Share. That one. No. Hang on. Just want to quickly show you. I want to hang on. Look. Empirical Formula. Right. There you go. If you want to have a go at one, do that one. There you go. It's given you real numbers. Yeah. I'm just being an idiot. I know. Rue, I've just made a hash of it with all the sounds Mr. Duncan makes. The demon in his room is probably so confused. Oh, so true. Have a go at that one. Shall I do it with you? I know my lesson is overrun now. I'm going to do this one with you folks because I can't walk away from that being such a mess. Can't do it. Right. List my elements. Change their percentages to grams. Looks like it won't. There you go. 76 grams. Divide it by 14. That's the atomic mass. And divide that by 1. So I'm going to get 17.6. That's easy. And then 82.4 divided by 14 gives me 5.88. Divide by 5.89. Divide them all by the smallest. 17.6 divided by answer gives me 2.99, otherwise known as 3. Yeah, otherwise known as 3. So my empirical formula is NH3. I'm done. By the way, the MR is definitely going to be 17. That's ammonia. It's not going to have been anything bigger. But there we go. So at least you've had a look at it. Do you round it up while solving Q? Okay, I've got another thing to. I'm not doing a very good job of this lesson, guys. If you run an empirical, formula, yeah, the process. If you take your percentage, yeah, you get it to grams, and then you divide it by the smallest, yeah, and you get. It turns out at the end of this process. Let's say you had CH, yeah, and it came out as being 1 and 2.5 at the end of it, yeah? Of all of this process, those are the numbers. You can't have half an atom. So what you will do is you will multiply everybody by 2 to get it to 2 and 5. That's to get it to a whole number. Yeah, we've divided it because we're always in this process of empirical formula. We're always going to get to 1 because we divide by the smallest, but we all know that it's not always possible to get 1, yeah, as a simplest whole number. So if you get a half, then double it. If you get a third, then triple it. Yeah. Anyway, I will put up the worksheet on the classroom. I'm finally done. 10 minutes over. Sorry, folks. Yeah, lost it. Not doing very well. Right. I'm going to leave you guys be. Have a good Easter, folks. I'll take care. I'll see you soon.